Hello, it's Immie and Mom, and today we're doing science.
Yes, today we are doing science just in time
for
Halloween, because it is October.
Yes.
And we see these certain things around Halloween. I'm not talking about zombies, ghosts, goblins, ghouls, witches, or even kids in costumes. No, there's something really cool that we see during the Halloween season that can be used as a science lesson. Today we are going to be talking about chemiluminescence.
Yes.
Show them. That's right. Like
right here. Glow stick.
You have to hold it up so the camera. Glow sticks. So we're going to be doing an experiment with glow sticks.
Yeah, and they're also bendy wires. See?
And we're also going to talk about some of the animals in our world, underwater creatures for today, that have bioluminescence, which is the production and emission of light by a living organism. It is a form of chemiluminescence. It occurs widely in marine vertebrates and invertebrates, like plankton, like from SpongeBob.
Plankton cute.
Plankton is bioluminescent.
Yeah. Plankton is an evil genius, and he's so cute.
Plankton is an evil genius, and he's also cute.
Yeah, because he's so tiny and cute.
Yeah, he also has that really fun song.
Yeah.
The fun song. F is for fire that burns down the whole town. U is for uranium bomb. M is for no survivors. I don't actually remember how it goes. It's been a long time since I've seen SpongeBob. By choice. Anyway, so bioluminescence occurs widely in marine vertebrates and invertebrates, as well as in some fungi. Do you know what fungi is?
Awesome.
Fungi is awesome. Mushrooms and other types of mushroom-like things. Fungus.
Yeah.
Microorganisms, including some bioluminescent bacteria.
Yes.
I wonder if you could have bioluminescent bacteria in your body and then you started to glow. How cool would that be? And last but not least, terrestrial invertebrates such as fireflies. So we're going to talk about a couple of bioluminescent creatures that appear underwater and talk a little bit about each one. And then we're going to head over to the sink and do an experiment with the glow sticks that kind of ties into the whole underwater thing, because we're going to have the glow sticks underwater.
Sorry guys, I needed to go for a second.
Okay, so I'm going to insert photos of each of the animals that we talk about in the video so you can see what they look like too. But the first one is the clusterwink snail. It shines its light through a magnifying shell, making itself look more imposing. You know why it might want to look more imposing? Do you know what that means?
It wants to glow.
It wants to glow, right? But it wants to look scary.
Yeah, why?
It wants to look tough.
Why?
So that it doesn't get eaten by other sea creatures. Yeah, it tries to make itself look tough and scary so that other sea creatures won't eat it.
So they have that kind of jaw?
Yeah.
It kind of looks like a rainbow black hole. A rainbow black hole.
Yeah, that is actually an atolla.
What's an atolla?
An atolla is a deep sea dwelling jellyfish.
Jellyfish
Like on
are
SpongeBob.
Yay!
SpongeBob has never been relevant before today, but I guess it kind of is now. So the jellyfish, the atolla jellyfish, has a bright light display that can be seen up to 300 feet. And researchers think that it does that to attract a protector. So, like, something really big will come and scare off the thing that was trying to eat the jellyfish in the first place.
Hold on. There's like huge jellyfish. Guess what it's called?
What?
The king jellyfish.
King jellyfish.
And there's also a princess jellyfish.
A princess jellyfish?
Yeah.
Cool.
And all the tiny ones are their soldiers.
Alright, now check this out. That is an Abraliopsis. Am I saying that right? Abraliopsis squid. That's right, that's a squid. It has small light organs.
Yeah, on its tentacles.
On the underside of its body for camouflage.
Yeah.
And uses illumination to blend in with the sky.
Yeah, is that with the red ones?
Yeah. So it actually is hiding up above the predators, which are trying to eat it, by mimicking what the sky looks like when seen from underwater. That's pretty darn smart.
That squid is pretty darn smart.
Yeah.
Does
Pretty
it like ice
darn
cream?
smart.
Hey, do you know some squids like ice cream?
Really? Like Squidward? Does he like ice cream?
Yes, he likes ice cream. What is that?
That is a Tomopterus.
Hey, I think I've seen those on Octonauts.
It's a sea worm. Okay, so
Seawormy.
you think you've seen that on Octonauts?
Yeah, because I saw
Because
the
Octonauts is actually really cool. They talk a lot about these kinds of underwater creatures, and I'm cool with that. He's come to me with, hey, I want to see a picture of something I'd never heard of, and it was an actual real-life sea creature. And we had a great teaching moment because he saw it on Octonauts. But anyway, so you can totally keep watching Octonauts.
Yay.
The Tomopterus is a sea worm. It's one of the few creatures that makes yellow light.
Cool.
If something disturbs the sea worm, it shoots glowing sparks out of itself.
Like,
Ow.
sorry.
This one is my favorite.
And my favorite.
For Halloween.
Vampire squid.
Vampire squid.
Actually, it's not a squid. And not an octopus too.
That is correct. The vampire squid is neither a true octopus or squid. It doesn't have ink sacs.
Yeah, but instead they have little tooth thingies.
Yeah, they actually have bioluminescent mucus.
Yeah, and they use their cover thingy to be camouflaged, like a plant of the sea.
So when the vampire squid is frightened, it fires a gooey cloud of bioluminescent mucus that surprises the attacker and gives them a chance to get away. They also use photophores on their bodies' undersides to hide their outlines against the sky. So you may be asking, well, what is a photophore? Photophore is the name for the light-producing organ that certain fish and other animals have. So the photophore is simply the name for the organ, the part of the body that has the light-producing element to it. So there you go. So we also have the Colonial jelly. This is a type of, do you know?
I forget. It was a long time ago. Jellyfish.
Jellyfish. I'm so glad that this actually included him in, that it was jellyfish. So it is a type of jellyfish. It grows to be about 12 inches, which is standard ruler, a foot.
And guess what it does when it gets disturbed?
What?
They tie people up and then turn them into jelly.
Oh, that sounds like a spooky story waiting to happen.
Yeah.
So this colonial jelly has this luminescence that nobody really knows why. Researchers think that maybe they use it to startle predators, but they really have no clue if that's correct or not. So, I don't know, maybe it just likes to look pretty.
Hello.
Then we have the Diopea comb jelly.
That's a jellyfish. A kind of jellyfish.
Yeah, it's a comb jelly. It's called a comb jelly.
Like a pine cone.
It kind of does look a little bit like a pine cone. It is hermaphroditic, so that means that it's both a boy and a girl.
So itself, it's married?
Yeah, kind of. So it can actually make more of itself. It can reproduce by itself. So it doesn't actually need to meet another comb jelly to live happily ever after with. So like the colonial jelly, which we just talked about, scientists don't really know why the Diopea comb jelly has luminescence. Again, they think it may be defensive, but they don't know. Last but not least is the red tide.
What is a red tide?
The red tide is the most common bioluminescent creatures. They are speck-sized, so they're like teeny tiny, plant-like dinoflagellates.
Wow.
And do we know what a dinoflagellate is?
Dinosaur.
Well, dinoflagellate is one of a large group of flagellate eukaryotes.
Hey, I've seen those on octonauts.
They are a type of marine plankton, but are also common in freshwater habitats. So they're just this little tiny eukaryote that is called dinoflagellates because it means whirling and whip. So I guess they look like, kind of like they turn. They almost kind of look like a top, like a toy top, a little bit. Like maybe when you'd see on those, like, the show where you build your robot and then you fight each other and you have like all of the like razor blades and the saws and all that. Yeah, it kind of looks like that. Maybe I'll throw up a picture of that too, just so you can see it. If you have not ever seen a dinoflagellate. A eukaryote, of course, is an organism whose cells have a cell nucleus and other organelles enclosed within membranes. So this is all biology. These speck-sized plant-like dinoflagellate blooms cause what is called the red tide. They flash brilliant blue to scare off predators when they're disturbed or caught in a wave. So, wondering why it's called red tide when, as we just heard, it luminesces blue.
Blue. Cool.
Shouldn't it be called the blue tide? Let's check.
Yes.
Red tide is a common name for a phenomenon known as an algae bloom, It is caused by a few species of dinoflagellates, and the bloom takes on a red or brown color. Okay, so when it's not luminescing, it's red or brown. When it luminesces, it flashes this pretty blue color. Probably something a little bit like this.
But that's purple.
Well, it's kind of blue. It looks blue on the screen. It looks purple in real life. Anyway.
It's kind of a purple bluish.
Right. So what we're going to do in the sink, and we're going to switch over to my phone to video this next part, we are going to run really hot water and really cold water in our double sink, and then we are going to compare and see if the temperature of the water affects the glow of the stick. What do you think?
Good.
Well, no, I mean, like, what do you think is going to happen? Do you think one type of water is going to make it glow more or glow less? Do you think it's going to have any effect on it at all?
Or explode.
You think it's going to make it explode?
Probably.
Well, hot or cold water?
Probably hot because it's so hot it could probably make all of them explode if you put all of them
Okay, so
in the hot water.
Immie wants to say that it's quite possible that the hot water will make them explode.
Yeah, it's quite possible.
Alright, so your hypothesis is that hot water will make glow sticks explode. Is that right?
Probably.
Alright.
And I'll put this somewhere for storage.
We'll come back here in a few minutes and film the water experiment, and then we'll come back and see whether the hot water caused it to explode.